Our next task is to deal with the limits of these vectored valued functions. Now, fortunately, taking the limit of our function r of t for our vector, we're just going to simply take the limit of each individual function, whether it corresponds to two functions, f of t and g of t, or three, f, g, and h, depending upon what we have. You just evaluate the limits as you normally would. For example, down here, I've got a couple problems. So we're taking the limit as t approaches 4 for our x, y, and z, which are three different functions. So this is going to equal, we essentially evaluated 4, provided that it's going to work and exists. That's our f of t. All right, so this middle one we're going to have an issue with and have to do something with, but let's see what happens at the end. All right, well, we can evaluate tangent of pi by 4, and we can evaluate our square root. However, this one here, we're going to be in a situation where it's 0 over 0. So there's a couple ways to do this. We can certainly use L'Hopital's rule to do it. In fact, that's probably going to be the easiest. Otherwise, we can factor out a t plus and minus square root of root t minus 2 and root t plus 2 from our denominator. That will work as well. So let's do that over here. So root t, not root 2. So our denominator, this is going to be root t minus 2 times root t plus 2. So we essentially have a square minus a square. T is a square of square root of t. So now we can cancel these and evaluate. So this equals 1, we don't lose that numerator, over root 4 plus 2, which is equal to 1 over 4. So this one here, so essentially this is going to equal, we've got 1, we've got 1/4, and tangent of pi by 4 is just 1. So this is going to be our solution to problem number 8. Again, that middle one took a little bit of work, but the other two are pretty straightforward. Hopefully number 9 will be more accommodating. We'll see. So this, we evaluate at pi by 2. And we can write it like that, like this other bit. So let's remain consistent and just write it how they've got it. So we can use an I there. There's no problem. Sine. That's J and ln. Okay. You could use a calculator certainly to evaluate the e of pi by 2. You don't have to. It's good as it is. It exists. E has a domain of any value, so there's no problem with that one. Sine of pi by 2, so I'm going to leave this alone. Sine of pi by 2 is 1, so this is just plus j. And ln of pi by 2, well, note that pi by 2 is greater than 0, so it's defined. Ln of pi by 2 is defined. So plus natural log of pi by 2. Okay, so that'll work for our answer there.